Hey everyone, and welcome to this explainer. Okay, let's just dive right into this, because today we're looking at something that is absolutely fundamental to our daily lives, yet it's completely invisible. We're going to demystify the unseen rules of connection, the very specific laws governing how every single one of our modern gadgets communicate with each other.
It sounds like a simple question, right? But seriously, take a second and really think about it. How do our devices actually talk? Imagine the sheer, unadulterated chaos of digital information flowing between billions, literally billions, of computers, phones, and servers worldwide. If there were no underlying traffic laws directing this massive flow of ones and zeros, it would be the ultimate digital traffic jam. Nothing would load, your messages definitely wouldn't send, and our whole interconnected world would just grind to a halt. Luckily for us, there are rules.
So the crucial point here is establishing exactly what we're talking about. First, let's set our baseline, data communication. We're defining this, simply put, as transferring data and information between computers and other electronic devices. And while that actual transfer might sound straightforward, the specific ways it's allowed to happen, that's where things get super fascinating.
To understand how that data transfer actually goes down, we kind of have to look at the grand divide in the data communication universe. Basically, every single time a device connects, it fundamentally falls into one of two primary modes. On one side, we have Simplex mode, which is strictly a one-way street, meaning data takes place in only one direction. And on the flip side, we have Duplex mode, which opens things up as a two-way street, where information flows in both directions.
Section 1. Simplex, a one-way street. So, Simplex mode is the unidirectional transmission of data. And unidirectional is absolutely the key word there. In this mode, the roles of your devices are completely rigidly fixed. A device is either permanently assigned to be a sender, or it's permanently assigned to be a receiver. There is absolutely zero traffic allowed in the opposite direction. It's kind of like using a megaphone, right? You speak into it, sound comes out, but that megaphone is never, ever going to talk back to you.
To really anchor this, because it can sound a bit abstract, let's look at some everyday examples of simplex communication. Think about a standard radio, a printed newspaper, television broadcasting, or even the books sitting on your shelf right now. When you turn on your TV or read a book, all that information is flowing directly to you. But you can't transmit information back to the television station through your TV set, and you certainly can't talk back to a book and expect it to, rewrite its pages. The data is strictly a one-way broadcast.
Section 2. Duplex, the two-way street. And this brilliantly illustrates how duplex mode completely solves those rigid limitations of simplex. It does this by allowing data to flow in both directions. We're moving from simple, one-way broadcasting to actual interactive communication. It opens up two-way traffic so our devices can finally respond to one another.
Now here is where it gets really clever, actually. The two-way street of duplex branches into two distinct subrules, and it's based purely on timing. Devices can either operate in half duplex, where data travels in both directions but only one at a time, or they can operate in full duplex, where data flows in both directions simultaneously.
Section 3. Half duplex, taking turns.
I actually like to think of half duplex as this ultimate exercise in digital politeness. Notice how at time 1, data goes exclusively from device A over to device B. Only after that's done, at time 2, can data travel from device B back to device A. Think of it like a narrow, one-lane bridge over a river. We've all seen those, right? Cars can cross in both directions, but they absolutely must take turns. If two cars try to cross from opposite directions at the exact same time, you get a massive collision. Well, the data works the exact same way.
You've definitely experienced this firsthand if you've ever played around with a walkie-talkie or a wireless handset. These are textbook half-duplex devices. When you press the button to speak, you are claiming that single lane of traffic. The other person, they can only listen. They cannot speak back to you until you let go of the button and effectively say, over. It just perfectly illustrates why data can flow both ways in this mode, but never, ever at the exact same moment.
Section 4. Full duplex, simultaneous chat.
Now, what's really interesting about this concept is how it represents a massive leap in capability, and it all centers on one really powerful word: simultaneously. In full duplex mode, data and information flow in both directions at the exact same time on the transmission path. So if half duplex is our narrow, one-lane bridge, full duplex is a massive multi-lane highway where traffic is constantly zooming north and south at the same time without any fear of colliding.
The absolute best examples of full duplex communication,
They're probably sitting right next to you right now. Your mobile phones, or even traditional landline phones. Whenever you're on a call and you interrupt the person talking, or you both just start laughing and talking over each other at the exact same time, you are successfully utilizing full duplex communication. Both your voice and their voice are traveling across that transmission path simultaneously. It's pretty cool when you think about it.
Okay, let's pull all of this together into a quick master cheat sheet. We started with Simplex. That's the one-way broadcast, like your TV or radio. Then we introduced duplex, the bidirectional two-way street. And remember, that splits into half duplex, taking turns like a walkie-talkie, and full duplex, talking simultaneously just like your mobile phone. Stepping back and thinking about it like this really locks in the entire hierarchy of how our devices transfer information.
Which pretty much wraps up this explainer. But honestly, it leaves us with a massive question for the future. We've established the fundamental traffic laws of data here: simplex, half duplex, and full duplex. But as our global data needs grow exponentially, and as we introduce literally billions of new smart devices into the world, what invisible rules will govern the devices of tomorrow? Will these current modes be enough, or are we going to have to invent entirely new dimensions of data communication? It's something pretty fascinating to chew on the next time you pick up your phone or turn on your TV. Thank you so much for joining me today, and keep asking questions.